The next problem is two blocks of masses m1 equals to 3 kg and m2 is equal to 1 by root 3 kg are connected by a light inextensible string which passes over a smooth peg. The blocks rest on the inclined smooth planes of a wedge and the peg is fixed to the top of the wedge. The planes of the wedges supporting m1 and m2 are inclined at 30 degree and 60 degree respectively with the horizontal. Calculate the acceleration of the masses and the tension in the string. So here also we are taking g value to be 10 meter per second square. Okay. Alright, see here, this is basically the figure. Okay, so this is basically the figure. So we have, let A be the acceleration of the blocks m1 and m2. Okay, and then let's say T is the tension of the string. See here, T is uniform throughout the string, correct? And one more thing which is very important is whatever the blocks we have, they are on a smooth surface, correct? So friction doesn't come into picture, right? Okay, see, next one is, see, the forces acting on the block M1. One is weight, which is vertically down, and the tension of the string, which is basically upwards, and the normal reaction, correct? See, I cannot say the tension is upwards, but just for your understanding sake, call it as weight is downwards, where tension is upwards and normal. Okay, so basically what we are looking at here is the total force, the net force on M1 along the plane will become M1G sine 30 minus T. Because see, whenever you have the weight, see, look at the figure now. If you look at the figure, so we have to resolve the weight into components, correct? When you resolve it into components, you are going to get m1g sine 30, that's along the same plane, and then m1g sine 30 minus t, because the tension is in the opposite direction, correct? So now what we do, so we are going to apply the Newton's law. Okay, alright, see, now once we apply the Newton's law here, so what are you going to get? See, you have m1g sine 30 minus t is equal to ma, basically, correct, the acceleration, right? Now for the second mass, if we try to calculate, see, for the second mass also same thing, you have m2g, but here it's m2g sine 60, correct? So m2g sine 60 minus t, so that will be the net force acting on the second body, correct? Right? So that's the second one. Now again same thing, we have to apply the Newton's law. We'll get Ft minus m2g sine 60 is equal to m2 into a. Right? Now what we'll do, we'll add these two equations. So if you add these two equations, you'll get A is equal to m1g sine 30 minus m2g sine 60 divided by m1 plus m2. Okay, m1 plus m2. Okay, now we'll put the values. See, we know m1, we know g, and we know sine 60, sine 30, correct? Now if you put the values, so you're going to get m1 is what? 3. So 3 into 10 into sine 30 is half, minus 1 by root 3 into 10 into sine 60 is what? Root 3 by 2 divided by 3 plus 1 by root 3. Correct? So this is basically the value whatever you're going to get. Right? Okay, now if you calculate this, so be very careful in calculating, because in the denominator you have 3 plus 1 by root 3. Right? Okay, so now if you try to calculate this, alright, see, what are you going to get? So initially you'll get 3 into 5, which is 15. 15 minus 5 divided by 3 plus 1 by root 3. Right? Okay, so if you calculate the whole thing, you're going to get this as 2.8 meter per second square. Okay, so this is basically the acceleration. Right? Now once you got the acceleration, now we need to calculate what is the tension. Right? So if you apply that, you will get, see, T is equal to m1 g sine 30 minus m1 into a, the first equation, right? So take m1 common. So m1 into g sine 30 minus a, substitute the values. You are going to get 3 into 10 into 0.5 minus 2.8, right? So you will end up with 6.5 Newton. So the acceleration is 2.8 meter per second square and the tension is 6.5 Newton. Understood? So whenever you have inclined plane, so you do the problem something like this. Alright, so go through the problem again so that you understand it better.